In this video, I will discuss about solving a problem involving polynomial functions. Suppose we have this situation. Martha decides to use a 30 centimeter by 24 centimeter cardboard to make a box where she can store her computer accessories. By cutting out squares of the same size from each corner and bending the sides up, she wants to form a box that can occupy a space of 1,400 cubic centimeters. The question is, how large is the square that should be cut from each corner? For our solution, let us illustrate the problem. Suppose we have a rectangle, which is the cardboard to be used by Martha to come up with a box. And this cardboard has two dimensions, two given dimensions, and these are 30 centimeters in length and 24 centimeters in width. And based on the problem, she will cut 4 squares from the 4 corners. Now suppose we have to draw broken lines for the side of each of these 4 squares. And since we are to look for the size of the squares, particularly the length of one side of the square to be cut from the 4 corners, then for the remaining part of the cardboard, the 4 sides are to be folded up so that from this figure, we will have this resulting box. And from each square, one side is denoted by x, since this is what we're going to look for, the length of one side of the square, which is in terms of centimeters, so this is x. And from this resulting box, we have 3 dimensions: the height, the width, and the length. For the height, that is the length of one side of the square from this figure. Okay. And this one right here has a width whose length is 24 centimeters minus 2x. And for the length of the box, that is 30 taken from this length, subtracted by the sides of the squares. So that is 2x. Okay, so that is 30 minus 2x centimeters. And the box is actually in a shape of what we call the rectangular prism. Okay, so that is the length, the width. Again, the box is in a shape of a rectangular prism. So therefore, what we're going to use here is the formula for the volume of the rectangular prism, and that is volume equals the length times the width and the height. And according to the problem, the space occupied by this box is 1,400 cubic centimeters. Okay? So taking this formula, the volume is to be represented by f of x that is equal to the value of the length. So from this figure, that is 30 minus 2x, quantity 30 minus 2x, multiplied by the width, whose value is quantity 24 minus 2x, and the height, which is x. And we have just derived a polynomial function f of x. So from this form, we're going to simplify the right side so that the resulting polynomial function would be expressed in its standard form. So simplifying the right side, we're going to multiply these two binomial factors using the FOIL method. So we have x multiplied by 30 minus 24, that is 720, minus 60x, that is 30 times 2x, minus 48x, that is the result when we multiply negative 2x by 24, plus 4x squared. So that is negative 2x times negative 2x. So we have a resulting four-term expression, okay, when we multiply these two binomial factors. And you will notice that the two middle terms are similar, so we can combine them. So negative 60x minus 48x, that is actually negative 108x. So we have a resulting trinomial expression to be multiplied by x. So using the distributive law, we can multiply x to each of these three terms inside the parentheses. So that is 720x minus 108x squared, multiply these two, plus 4x cubed. And this is your f of x. Okay. Next, of course, the function is not yet actually written in standard form because the right side expression is arranged in ascending powers of x. Okay. So, from this form polynomial function, we can now solve for the value of x, which is the height of the box. So, from this polynomial function, we're going to substitute the value of f of x, which is according to the problem, that is the volume, which is equal to 1,400 cubic centimeters. So that will give you 1,400, replacing f of x. So at this point, the polynomial function is now a polynomial equation. So we're going to transform this equation into its standard form or general form. It means we're going to transpose 1,400 term to the other side and rearranging the terms in ascending powers of x. So the resulting polynomial equation would be 4x cubed minus 108x squared plus 720x minus 1,400 equals 0. And you will notice that this equation has a common factor of 4 from each of uh, the terms. So we divide each term on both sides by 4. So that the simplest form of the polynomial equation would be x cubed minus 27x squared plus 180x minus 350 equals 0. And from this polynomial equation, we can now solve for x using the synthetic division. So we will take all the coefficients and constant term on this expression. So these are 1, negative 27 plus 180 minus 350, together with one possible root. And that possible root can be taken from 350, which is the factor of the constant term 350 or negative 350. Most probably, that possible root to be used in the synthetic division is 5. Okay? Although we could use other root of 350, but what we're looking for is the root when we used in the synthetic division will result to a zero remainder. So in this case, I chose 5, and let us see if from the synthetic division, uh, the result is a zero remainder. Okay, let's begin. So let us bring down 1. 1 times 5 is plus 5, positive 5, added to negative 27. That will give you negative 22. Negative 22 times 5 is negative 110. Added to positive 180, that will give you positive 70. Then positive 70 times 5 is positive 350. Added to negative 350, it will result to 0. So at this point, we have just determined the root of this equation, which is 5. And most probably, that is the value of x, which is the side of the square to be cut from one corner of this cardboard. So at this point, we have just solved for the value of x. But then we need to look for the other possible values of x, which is taken from the first row of numbers. And we know that from the synthetic division, the last row of numbers are the coefficients of the quotient, having the degree of 2. Since this is remainder, this is the constant term, and this one has a degree of 1. So restoring the variable x from this row of numbers, we have 1x squared minus 22x plus 70 equals 0. So the equation that we have here is actually a quadratic equation that can be solved by any of the methods possible. We could use factoring, but then observing the coefficients and the constant term from this equation, this quadratic expression is not factorable. So we cannot use factoring here. But there is a possibility that we could solve this equation using the quadratic formula. So assuming that we use the quadratic formula solving this equation, the roots are, or the value of x could be 11 minus square root of 51, or the value of x could be 11 minus square root of 51, or that would be 11 plus square root of 51. Now, considering the decimal equivalent, since this is an irrational value, taking the decimal equivalent of this irrational value, for the first value of x, that is approximately 3.86, or taking this, the decimal equivalent of the second value of x, that is approximately 18.14. Now, so therefore we have 3 possible values. So one side of x to be cut from the corner of this cardboard is either 5 centimeters, 3.86 centimeters, or 18.14 centimeters. So among these 3 values, which is or which are the possible sides, which among these 3 values, which is or which are the possible values of one side of the square? And this is the answer. X can either be 5 centimeters or 3.86 centimeters, which is the side of the square to be cut from the four corners of the cardboard. Now, why is it that we did not include the third value, which is 18.14 centimeters? Simply because if we consider the third value of x, which is one side of the square, from this rectangular cardboard, one dimension will result to a negative value. Okay? So, let's say we take the value which is 18.14. Okay? So, there are two 18.14. So, 18.14 times 2, that will give you 36.28 centimeters, which is now longer or greater than 30 centimeters. So, pag sinubtract natin ang 30 by 30 centimeters by 36.28 centimeters, the result is negative. And there is no such thing as negative dimension in any rectangular figure. Therefore, these are the only values acceptable for x, which is the length of one side of the square.